www.ignou.ac.in.
नमस्कार, मैं MP Mishra, Faculty School of Computer and Information Sciences, IGNOU. I am with you in this particular session on a particular topic related to object-oriented analysis and design. And in this session of 20 to 25 minutes, I will be discussing with you about what is state machine diagram and what kind of utility of this diagram is when we talk about the analysis and design of the system, and how we draw this particular diagram, what are the symbols or components which are used to draw state machine diagram. So whenever we talk about designing of any system, we try to see a comprehensive view of the system, and that comprehensive view basically takes care of the static of the system, dynamic behavior of the system, and what kind of different objects are there, or what kind of different entities are there which are involved in the whole process of the performing the activities of the system, and how they are interacting with each other, and ultimately by interaction of those different entities, what we are getting as a result is our actual solution. So when we try to visualize a system, we try to depict or describe that context. State machine diagram is one of the diagram which is very useful to represent the dynamic behavior of the system, and we will see how this particular diagram represents the dynamic behavior. So let us start our discussion and see what actually state machine diagram is. Kind of specification which basically tells about the dynamic behavior of individual, class, objects, use case, and entire system. So if you are talking about individual class objects, or the objects involved in the processing of different activities of the system, and use case diagram, and entire system also. It means that you can draw a use case diagram which is basically taking care of depicting or representing the dynamic nature or dynamic behavior of the system in context of the different objects involved in the system, or overall working scenario of that particular system, that is the use case, or the complete system in itself. So when we talk about the complete system, obviously a system consists of several subsystems. So how different subsystems are participating in the actual processing of the certain kind of request or certain kind of operation, that also can be represented with the help of UML diagram. It means you will be having different components, and those components will make little more clear to us. And a state machine is a behavior model. State depend on the behavior of objects, or you can say that whatever object's behavior is there, that particular is being interpreted with the help of the state of that particular specific object. And if we talk about the state, combination of those values is defining the state of that particular object at a particular moment of time, and one thing you will find that in a system, objects are bound to change their state on a certain kind of activities or certain kind of operation. And when we very specifically talk about the UML modeling, we say event. So certain events are there. If those events are triggering or those events are occurring, on the basis of those events, the state of the object changes. State of the object changes means the combination of the values of the different attributes that particular object possesses that change, and on the basis of that we have subsystem, a package and a complete system, as I said earlier also. So here you can say one more thing has been included here, that is the package. It means that it is working as a separate component or separate module which may be used as part of the development of whole system. And state diagram can be seen as a device that stores the status of object. Status of object means the value of those attributes associated with the objects at a particular moment of time. That particular state is being stored, and certain events on the basis of those that particular state is changing, that is also depicted and shown in the state diagram. So state diagram basically show the transition of the state. It means that from one state to another state you are moving, and the cause of that movement is certain kind of event. Now let us talk a little bit about event. If we talk about state machine diagram, it describes all the events, states and transition of a single object. So if I am taking one object in a system, how this particular object is completing its journey from its inception to the completion, means total or whole object life cycle we are trying to depict with the help of state transition diagram. So if we are taking a single object and we are trying to trace out the different events which are being performed on that particular object and how object is changing its state, if we are trying to show that particular through a diagram, we will be using the state machine diagram. Now if we talk about the events, so there are basically different kind of events like signal event, object are responding to it, call event, certain object are calling certain specific operations, time event, certain time bound activities are happening. It may be a time interval, within that something is happening, or it is some specific time which is going to complete, and on the basis of that certain decision to be taken and certain activity to be performed. So time event and change event, what kind of decisions are being taken. So you can say that on the basis of certain condition, if the condition is satisfied, certain operation is going to be performed. If condition is not satisfied, you can say that particular operation cannot be performed. For example, we can take one very example related to examination system. If one specific student is about to appear in the examination and the student is not having the required criteria, example related to change event. So further, if we talk about state machine diagram, so we can say that a state machine diagram is used to represent the condition of the system or part of the system at a finite instance of time. So we are talking about a specific moment fall in the specified category of the event, and on the basis of that object is going to participate in certain activity, and once object is participating in certain activity, the state of object is most probably will change, and that particular change you have to store and you have to move further from one state to another state. And one example we will see that how actually a simple admission process, if some student is coming, let us say, to take admission in a university or in some institution, then what will be the process? The student first will be registering to themselves, and then they will be filling up certain information, and on the basis of that some more event will trigger and that will generate or that will lead towards the payment of the fees, and on the basis of the status of the payment of the fees, certain more activities will happen. So it's all depends that how sequentially one student object is moving from one state to another state. These all are being determined with the help of the participating in events or occurring of the participating event in that particular system, and on the basis of that object state is changing. As I said, state diagram basically depict the system's life cycle. Now one question may arise here that why we are doing a study of this particular, we are studying the state machine diagram, and if we are making state machine diagram, what advantage we will get? So first of all, we will get a visual representation of how the participating objects are reacting to different event, and on the basis of that the kind of action which are being taken. Basically in state machine diagram, the detailed logical explanations are not given. It is only shown that on the basis of certain event, object is moving from one state to another state. How it is happening, those details are not shown in this. The state machine diagram provides a visual representation of various states a system or an object can be in, as well as transition between those states. So we are having a state machine diagram. You can see that object is at a particular state, on the basis of certain events some transition will take place. Accordingly, in the system, the objects for which we are emphasizing more at the time of implementation, we will try to take care of those things, and we will take note of those different events. On the basis of that, the state of objects are changing, and accordingly we will make the state diagram for performing several activities or several type of classes of objects or subsystems which are participating in certain kind of activity, and they are going through certain events to perform the different operations. So if you are doing modeling and you are going to make the state machine diagram, so for example purpose, obviously in literature you will find one or two example related to certain kind of problem solving, but if you are taking a complete system, and in that system if you are trying to represent or visualize or depict the state, and accordingly you will be making different state machine diagrams for your representation in the design. State machine diagram is also called state chart diagram and state chart diagram or state transition diagram. So when it is asked to you to explain about state machine diagram, and in some place you find that it is being asked you to explain about state chart diagram, so these three are one and the same. State machine diagram model efficiently the interaction and collaboration in external entities and system. External entities are nothing but certain participating objects, and those objects may be, there is a single object that maybe it is a subsystem, or it is a composite subsystem, or it is part of the system, or it is certain package, and how those things are participating and how they are collaborating to perform certain operation. If you are taking a particular scenario, in that scenario you can draw the specific state machine diagram. It models the event-based system to handle the state of an object. Now, few more examples we can take if we are going for online shopping. So, first, as a participating object, what we do, we select the certain items, we try to search certain item, we find the list, we choose the item. If item is within our budget, we select that particular item, and then we go for the processing. And once the processing is being done, sometimes you choose the option of cash on delivery, sometimes you choose option for the online payment. During online payment, suppose you are performing all the operation, but at a stage you have to submit OTP, and that password is not available to you due to certain network failure or certain network issue, if you don't submit, then what will happen? Then your whole transition up to that stage, or your whole transaction from one occurrence of the event to another occurrence of the event, it will be aborted. It means there may be a situation, in that particular situation the processing is aborted due to certain condition, and if things are aborted, then further it cannot be done. One very interesting example here we can take, suppose from this studio transition is being taken place, but due to certain technical problem, if we assume that for a moment the light fails, means the whole process is aborted. So this whole event which is happening, the transition from one state to another state is happening, that will stop immediately, and then you have to think about another way of performing that operation, aspect associated with system management later on. But if certain situation of that kind is happening, that kind of event is occurring that is not leading towards any kind of solution, then that states of a component within a subsystem. So it is not representing only the state of the object, it is representing the state of subsystem also. So that subsystem may be composite object, that subsystem may be package. So it's all depend that what kind of modeling you are doing or what kind of solution you are looking to get the diagrammatic representation of state machine diagram. Now one question arises that if we can do these many things, then how we can answer one specific question, why state machine diagram? So as I said, the main purpose of this diagram is to depict each state of an individual object. It represents an interactive system and entities inside the system. It records the system behavior in the system. So it is providing these many importance to the developer. Basically, when we are making these diagrams, basically whenever we do analysis and design, so that design document is used for the purpose of development. It is not user certain operation on the basis of occurrence of certain events. So we are saying that if this particular event occurs from this state to this state, object is moving. So that diagrammatic representation we can give. State machines are useful for modeling the real-time system, because we are showing the scenario in which the events occurrence and their effect on the object movement from one state to another state is being depicted. That is why real-time system can be modeled. The state machine diagram showcase how a system responds to event and transition between these different states. So for that purpose we can make the state machine diagram. It showcases how a system responds to event and transition between different states. So whatever we are talking about, we are concentrating at two important points: object, event, and on the basis of that event, how transition is taking place from one state of the object to another state of that object. Several examples you can take in real life. For example, cash deposit system, ATM withdrawal system. So you are performing certain operations, your activities are being performed, but if you have to make a state machine diagram for ATM system, then you will say that user is there, user in either deposit the cash or withdraw the cash, or if only the user is checking the account status, in that case the object, that particular account object is not changing, so state will not change in that particular event. But in majority of the event you will find that state of the object change, whether you deposit the money or you withdraw the money. On the basis of that, the state of that account object will change. The account balance is going to be affected due to these operations. That is the reason. It shows how a system responds to event and transition between different states. Now let us take one more example. Suppose one student is appearing in the examination. So once examination result is declared, that examination result declaration is nothing but it is event, and on the basis of that event, it will be decided that whether that particular individual student is going to change its state from one semester to another semester or not. It visualizes an object state from its creation to its transmission. We use it to state the event responsible for change in the state without showing the process. So in state diagram, we are not going to show the process. As I said earlier, depicting event-driven object in a reactive system. It or in a specific business solution of a specific problem. It describes how an object moves through various states within the system in its life cycle. So whole life cycle of the object is shown here, showing the overall behavior of the state machine or related. We are having initial state. For initial state, we use the filled circle. Then we are having for the decision box, that is the diamond. Then we are having rectangle, that is state box. And then we are having final state. Two circle, the outer circle is hollow and the inner circle is filled. These are the basic symbols which are used for making the state diagram. And if we are having composite state, then we use this particular diagram to show the composite state. And if we are moving from one state to that state itself after performing certain operation, then that is known as self transition. For that we use this particular symbol. And if we are having a condition where we are not moving anywhere and system is at halt, so for abort we use this particular symbol. And there are few more things which are used. One is the very important part of the this state machine diagram, that is transition. Transition shows transition from one event to another event, and we show it through the arrow, and on the top of the arrow we label the cause of transition. Fork and join is also used. Fork is used to represent a state splitting into two or more concurrent state. It means if we have reached a particular moment, and on the basis of that, if we are splitting two different activities to be performed and two different state of the object may occur due to that particular point of processing. You can see here at this point we are splitting this particular into two or more concurrent states, and join two or more states are joined together to represent a convergence into one occurrence of an event or state. Then we use join. It means two events are being performed and they are being converged, and they are further going to be at a point where that synchronization or concurrency of coverage is occurring. So that is shown with the help of join. Here one example you can see on the screen. Very simple. For example, in registration of a student in admission system, first you fill the form, that is the registration activity or registration process. Then program is selected after fee is paid or not. If fee is paid, the student is enrolled in the program. If fee is not paid, it is aborted and it will not move further. So once fee is paid, then you can see here two different events are being generated. One is student ID is assigned, student supervisor is assigned in the case of the PhD student, and then study center is assigned, and all these things are then being converged, and then another event occurs, that timetable and the ID is being sent to the student. So this is one example through which you can very easily visualize that how a student object is moving from one state to another state, and the state of the student is changed. Once the student has paid the fees, the state of object is changed and now object is in different state. The status of the fee payment is positive, and on the basis of that some more thing is being assigned to that particular object, like student ID and then the study center allocation in a specific case of IGNOU learners, and PhD students are there registered, and then the supervisor allocation and many more particular process or that particular activity. You will see that in that different events are occurring at different stage of time, and on the basis of that the state of that student object is changing. So this is the example. So in this particular session we discussed about what actually state diagram is, how this diagram is useful for representing the dynamic behavior of the system, and what are the components and symbols used for making the state diagram. And then we have seen that how we can draw a state diagram with the help of an example. So I hope that you will be practicing more examples and you will be drawing few state diagrams, and you will be seeing that how different events occurring in the system is affecting the things and how the state of the objects are changing. So with this, thank you very much.